Okay, good morning to all of you. Myself Raju. I'm going to give presentation on transformer. Transformer is a very important device for all electrical distribution transmission for the electrical power. So transformer is a static device which transfers the energy from one circuit to another circuit without changing any frequency. So it is converted AC supply into AC supply, transfers the AC supply to load for AC. There is no change in frequency. So here introduction. So here the transformer is a static device which is used to transfer electrical energy from one AC circuit to another AC circuit without changing frequency, and electrical energy is generated and transmitted at an extremely high voltages. So at generating plants, we use step up transformer for stepping up the voltage ranges from low voltages to high voltages for transmission purpose. For remaining demand at load centers, so we step down the voltages from high voltages to low voltages. For utilization, voltages are mainly for three phases 415 volts, and for single phase 230 volts at 50 H. So these all are done by using a transformer. The voltage is to be then reduced to lower value for its domestic and industrial use. Next. So here block diagram of total power system generation. At generation, it is generation plants 3.3 to 26 kilovolts. It is step up by the step up transformer. There here it is the transmission system. So transmission system, high voltages transmit from generating to distribution centers. So at distribution also we use step down transformers. That is suppose 6.6 kilovolts transferred to 415 volts, step down by 415 volts at consumer ends. When the transformer changes the voltage level, it changes the current levels also. Current, suppose voltages increases, current decreases, current step down, and current increases means voltages down. So, but at power all equal both side for one center to another, one circuit to another circuit. So it is a mainly it consists of magnetic core, and it provides low reluctance for the flux magnetic flux. So basic principle of transformer. So mainly it consists of magnetic core, and core is made up of silicon steel laminations to reduce the eddy current losses. So CRGO, mainly we use CRGO, cold rolled grain oriented steel, to reduce the eddy current losses. That nothing but I square R loss, small amount of I square R losses in the core. So we use another for winding purpose, we use copper winding. So here number of turns in the primary winding is N1, number of turns in the secondary winding is N2. EMF induced in the primary winding is E1. EMF induced in the secondary winding is E2. So here NP, number of turns in the primary, NS, number of turns in the secondary. So whenever any winding, it consists of two windings. So that is whenever any winding is connected to the load supply, that is known as primary winding. So it is denoted with uh, primary V VP. Voltage across the primary winding is VP, and any winding is connected to the secondary is known as any winding is connected to the load is known as secondary winding. So current flowing through the primary winding is primary current. Secondary flowing through the secondary winding is known as IS. Primary current is IP. So VP is the applied voltage or supply voltage. Vs is the terminal voltage or secondary side voltage. So here, what is the basic principle, working principle of transformer? It works on the mutual induction principle. The primary winding is connected to the single phase AC supply, and AC current starts flowing through the primary winding. So current flowing through the any winding, it creates some magnetic flux. So the AC primary current produces an alternating flux that is denoted with pi. So units of flux is Webers in the core. Most of this changing flux gets linked with the secondary winding. So this flux flowing through the core, magnetic core, and it is linked with the secondary winding. Then in secondary winding also some EMF is induced. That EMF is known as mutual induced EMF. So the varying flux will induce voltages into the secondary winding according to the Faraday's law of electromagnetic induction. So what is the working principle of transformer? It is Faraday's law of electromagnetic induction. Voltage level change, but frequency, that is time period, remains same. So sinusoidal, both sides are sinusoidal. So time period is same. That's why frequency is same. Frequency is nothing but number of cycles per second, or it is the reciprocal of time period. So in between the primary and secondary winding, there is no electrical contact between these two windings. Electrically, these two windings are electrically isolated and mechanically isolated each other, but uh, energy transferred from primary to the secondary by means of mutual induction only. So primary winding means any winding is connected to the AC supply is known as primary winding. Secondary means it is connected to the load. Energy coupled between the windings by the time varying magnetic flux that passes through both primary and secondary windings. So what is the working principle of transformer? It works on the Faraday's law of electromagnetic induction. So whenever current flowing through the primary winding, that creates some flux. So that flux cut by the primary winding conductors. Then according to Faraday's law, conductor cuts the magnetic flux. Then EMF induced in that winding, so in that conductors, same as so in primary winding E1 is induced, so that is known as self-induced EMF E1. So next, this flux flowing through the magnetic core of the transformer then links with the secondary winding, means flux cut by the secondary winding conductors. Then in secondary winding conductors also some EMF induced. That EMF is known as mutual induced EMF. This total process is known as working principle of the transformer, mutual induction principle. So types of transformers. Transformer types. The transformers are of four different types depending on the arrangement of the core and the winding. So mainly step up transformer, step down transformer. Step up transformer. So number of turns in the primary winding is less than number of turns in the secondary winding. So otherwise transformation ratio K equal to N2 by N1. K greater than 1. K greater than 1 means so number of turns in the secondary winding is more number of turns in the primary winding. So it is nothing but step up transformer. So step up transformer mainly used at generating plants. So transformation ratio less than the 1. So means N2 by N1 less than 1 means number of turns in the primary winding is more compared to number of turns in the secondary winding. This type of transformer is known as step down transformer. Step down transformer used at different locations, substations, distribution level, and at utilization level, some electronic devices also. So according to construction, these are two types, core type and shell type. The magnetic core is a stack of thin silicon steel laminations about 0.35 mm thick for 50 Hz transformer in order to reduce the eddy current losses. These laminations are insulated from one another by thin layer of varnish. So this is the core type transformer construction. Winding iron core coils. Shell type transformer. This is the construction of shell type transformer. So comparison between the core type and shell type transformer. The core has only one window. In shell type time, core has two windows. Winding encircles the core encircles the winding. So core is surrounded by winding and core is winding is surrounded by core in shell type. So cylindrical windings are used. Sandwich type windings are used in shell type. Easy to repair. Core type transformer is easy to repair. It is not so easy to repair. So better cooling since more surface is exposed to the atmosphere. Cooling is not very effective in shell type transformer. So construction of transformer. Most important parts of transformers, the windings, coils, and the core. Core is made up of silicon steel laminations. So winding are mainly used copper winding. Some other parts such as suitable tank, conservator, bushings, breather, explosion vent, etc. are also used along with the core and windings. So this is the construction of the transformer. Applications of transformer, step up and step down voltages. So whenever we want step down voltages, we go for step down transformer. Step up voltages, we go for step up transformer. Measurement of current in single and three-phase system. So current CT in CT transformer, current transformer and potential transformer used for measurement purpose. Measurement of voltage in single and three-phase system. Measurement of power, measurement of energy also. Thank you.